webinar. I'd also like to thank Matthias for organizing this webinar specifically for the members of the Ortigas Center Association. But of course, we welcome all our guests and friends. And I'd like to welcome all our members, their staff, and our friends as well. And I'm sure we will all learn a lot about quality of air, HVAC, and COVID-19 from our distinguished speakers. Thank you once again. Good afternoon.
Great, thank you so much, Luz, and thank you for the Ortigas Center Association for really co-hosting this today and inviting their members. So this is great to have you all here, and we welcome you to our technical roundtable. That's the idea today, that we go into the technical details of the topic and really try and identify where are we with the COVID risk that we are facing now. Actually, this webinar is a follow-up on the last webinar. The last webinar, we went already into the subject, but the conclusion at the end was we want to dig a little bit deeper and go into the technical details. That's why I'm so happy to have three real distinguished experts with me today here on the panel. But just for an introduction, I think where we are now is that we have all realized this virus continues to spread. It's difficult to contain it. We have been on the lockdown. We are starting to open up our offices, our malls, restaurants, and other premises, depending on the country we are living in. And we are realizing that people are still scared. And we ourselves are challenged, how can we minimize the risk of virus infection? In the early days, it was mainly believed that most of the infection is deriving from touching surfaces that have been infected, or the large virus droplets that might directly come from somebody sneezing next to you. But I think you have seen it as well. Last week, over 200 scientists wrote a letter to the WHO saying we need to pay more attention to those small little aerosols that seem to be traveling around, that seem to be airborne, and that seem to be impacting the rate of infection. Now, before we actually start with our discussion and the panel, I have a little poll as well, one or two other rules. You can ask questions anytime as we go along. There will be a Q&A section. We already have one person commented, okay. You can use the Q&A section to actually, I need to reshare the screen here. You can use the Q&A section to actually ask questions anytime as we go along. I will pull up the first poll and I will launch the poll now. You are all allowed to vote. You can vote with your name. You can vote anonymously. What do you think is the most prominent source for COVID-19 virus infection? Is it touching a contaminated surface, someone infected sneezing next to you, sharing food or drinks with somebody infected, breathing in airborne COVID aerosols? Not sure. You only have one answer, so choose the one that you think is the most risky one, and then it will be very interesting for us to see what is our general perceived opinion on those issues. Okay, we have the majority of people have voted already. I'll give it another 10 seconds and then I will close it. We have 65% of all of our participants have voted already. So we have nearly 70% now. Let me close it now because we are above 70%. Excellent, 75%. I will end the poll and give you and share the results with you. And very interesting. I think you should be able to see the results now. What do you think is the most prominent source for COVID-19 virus infection? The number one choice that you have identified is breathing in airborne COVID aerosols, 38% of all of us. Then 28% think somebody infected sneezing next to you, touching contaminated surfaces, 24%, and then sharing food with somebody infected, fairly low, only 10%. So the airborne particles, that is our perceived #1 risk. And that will be one of our main focuses today as well. We are gonna have a technical discussion because it's so important that we go into the detail, we try and understand better and identify what possible solutions are out there to enhance our knowledge and to inform what response we can take, what action we can take on a personal level at home, on a professional level, in the office, in the mall, in the restaurant, in the hotel that you're responsible for, to take the appropriate action. So this is a very interesting result, and it confirms that we really need to focus on those kind of issues. So I would like to hand over for the intro presentation to Dustin, our first speaker. He is the CEO of uHoo, and he will focus on the subject of a virus index that they came up with based on scientific research. How can you fine-tune your air quality indoors to deactivate the virus faster than if your air quality is out of sync? So Dustin, I'll hand over to you, and we're looking forward to your presentation.
All right, thank you, Matthias. Hi, everybody. Good afternoon. Nice to meet you. Let me share my screen so that I can put on my slides.
Can you speak a little bit louder, Dustin, or move the mic closer to
sure.
your...
Is this better?
Yeah, this is slightly better. Thank you so much.
Okay, all right. Can you see my screen now?
Yes.
Okay, perfect. All right, so as a brief introduction, our company is called uHoo, and we position ourselves as your first step to clean air. And what we do is we help you understand the quality of the air that you breathe, both at home and in the workplace. And by understanding what you breathe, you would be able to take proper action. So our main emphasis really is to help you improve your health and well-being, both at home and in the workplace. And most recently, just last month, we launched the uHoo Virus Index. This is a world first, patent pending, and the only real-time assessment of virus survival using air quality data. So what we can tell you with the virus index is how to create an environment so that you can deactivate COVID-19 simply by adjusting the air quality in your space. So by doing that, you would be able to reduce the survival risk and the transmission risk of the virus. And to give you a bit more details on this, there is, based on how the coronavirus is like, you cannot really detect it in real time because it's really small. If we look at a comparison, the dust particles that we often see or we can breathe in the air are usually the PM10 and PM2.5 particles. It would be 10 microns in size and 2.5 microns. If we compare that to our red blood cells, the ones inside the body, PM2.5 is already smaller than the red blood cell. And if we compare it to bacteria is only 0.5 micrometers. And the coronavirus is so small that it would be very difficult to be able to detect it in real time. So how do we actually address this problem? We don't really want to detect coronavirus in real time, but when we understand the environment in which it survives, we can create one that would be detrimental to its survival. And that's the whole concept of the uHoo Virus Index. And there are specific thresholds that we need to achieve to be able to reduce the risk of coronavirus surviving and being transmitted. And these are the 5 parameters that go into or enter the calculation of the virus index. And these are the safety thresholds. So these thresholds are based on research from the WHO, the CDC, and different other medical and virology journals and scientists around the world. So there is general consensus that these would be the parameters that we need to achieve to be able to reduce that risk. And to show you a bit more details on how the research was done, researchers have shown that if you put the coronavirus in a specific environment in different types of humidity and temperature, their survival rate changes. If you look at the black line, what this means is that your relative humidity is at 20% and your temperature reading is at 20 degrees Celsius. And if that is the kind of environment that you have, it would take approximately 14 days for the viruses to reduce to just 10% of what it is originally when it first appeared. And if you look at the green line, what this means is that if your humidity is at 80% with the same 20 degrees Celsius temperature, it would take approximately 10 days for it to reduce to just 1% of its original and to be fully neutralized in 14 days. But if you are able to create an environment that is at 50% humidity and 20 degrees Celsius, you can see that just a little over a day, you would already be at 10%. You've reduced the virus count by 90%. And just before hitting 2 days, or roughly 36 to 40 hours after, it would be below 1%. So by creating this kind of environment, you're reducing the chances of the coronavirus surviving. And by reducing that chance of surviving, you're actually reducing your risk of being infected as well. And another parameter that we measure would be nitrogen dioxide levels. This study was conducted by Tel Aviv University, wherein they analyzed the data from the European countries across Italy, Spain, and Portugal on how the nitrogen dioxide levels affected mortality among those who were infected with the coronavirus. And what this shows is that the higher the nitrogen dioxide levels in the cities where the coronavirus was infected people in, the higher the mortality. And the primary reason for this is it weakens the immune system of the person. So if in case you get infected, you won't be able to fight the virus naturally. That's why the death rate goes up. And it's a similar concept when you look at the PM 2.5, because these particles are small enough that can go straight to your lungs, that it cannot be filtered out by your nose or by the other fibers in your body. And these are the particles where the coronavirus can attach itself to and stay suspended in the air and become airborne. So by reducing the count of PM 2.5, you can actually reduce the chances or the risk of coronavirus being airborne. And the other parameter that I mentioned earlier was carbon dioxide. That is a very good representation of ventilation or air exchange. So by reducing carbon dioxide levels, it's basically showing that you are able to exchange air within your office or within your home much more efficiently. And that means that you would have fresh air and you flush out other particles or other gases or components or air pollution out. And that reduces the chances of coronavirus actually surviving as well. So if we look at, let's say, in the Philippine context, we have deployed our solution in different offices already. And most recently, we have deployed uHoo in the COVID ward of 2 hospitals. And they're using it, they're actually using the solution to adjust their environment so that it would be better for the patients in there and for their staff as well. Yeah, so that's a quick introduction on what the uHoo Virus Index is about. And yeah, open for questions.
Great, great. Actually, we'll do the questions later, but can you go back to the slide where you show the overview over the parameters? I just want to re-emphasize that here. Temperature 19 to 24. And what was interesting as well, some of the early high death rate and high spreading experiences in Europe were very low temperature places. Ischgl in Austria, the ski resort, which is seen in Europe as the main super spreader event, very low temperature, very low humidity there. And in northern Italy, where most of the early deaths were, was as well ski resort areas, very cold places. Yep. So that's interesting. And then the carbon dioxide, I mean, the carbon dioxide, as you said, is a proxy for how well you are able to have fresh air in the place. I think we have a couple of friends here from ADB in the call today as well. I used to be a consultant there many years ago, and already at that time, the ADB and a couple of the main meeting rooms had carbon dioxide sensors. When it goes above a certain level, the air handling unit kicks in and brings in the fresh air. So you can really use this as a good proxy for how well your systems are working and how much you're getting fresh air in, especially in populated rooms. And what I've observed in a lot of modern offices, you have a open office design. You then set up small meeting rooms in the office that I sometimes work in Taguig as well, and there's no fresh air coming in. And I can see the CO2 levels very high. People feel sleepy because of high CO2 levels, but this is as well a risk for the longer survival of the COVID virus. The higher the carbon dioxide, the more negative that is for us trying to get rid of the COVID virus fast. So these are the parameters here that you should target. I actually bought a uHoo 3 years ago when my baby daughter was born. I'm struggling with the temperature because as a hardcore environmentalist, I usually don't cool it down to 24 or below. I mean, I usually have it 25, 26, 27. Is that still okay, Dustin?
Yeah, that's still okay. That's still fine, as long as you keep the other parameters in check.
Yeah, I just checked. My virus score is 3, so quite good. I'm like okay on most of these places. Just if there is open burning in the neighborhood and the PM 2.5 goes up very high, then we have a problem. Great, excellent start. Thank you so much, Dustin. If you have questions, feel free to put them in the Q&A already. We will come back to that later on after we have had all the 3 presenters give their observations, their technical knowledge. I might ask 1 or 2 questions just to reconfirm like I did with Dustin now. So Joel Jude, you are on next. Can you please share as well your presentation and let us know your views on this? You are a mechanical engineer, right? You are the man who really knows all these issues about HVAC and things like that. I really wanted to make sure we get an HVAC expert here into our discussion, because that is one of the main questions. How should you run your systems? So over to you, and we're looking forward to your presentation.
Hello everybody. Can you see my screen well?
Yes.
Great. Okay, so thank you for the introduction, Matthias, and thank you, Dustin, also for that presentation. Actually, the things that you have said about the CO2 levels and the relative humidity is also related with how the HVAC would affect those things. And this is a quick presentation, just 4 slides, on what parameters we should control, or that we should control in order to achieve those levels. Okay, so 3 things that we have to check, or that we have to understand in order for us to optimize our HVAC is operations and maintenance, ventilation, and filtration. So this statement from ASHRAE, which is the primary, I can say the primary authority on HVAC design and operations, says that transmission of SARS-CoV-2, the virus, through the air is sufficiently likely that airborne exposure to the virus should be controlled. So changes to HVAC can reduce airborne exposures. This was published around May, right? So in May, they're already speculating that there are aerosol, that you can contract the virus through aerosol. First is operations and maintenance. Of course, we have to disinfect high-touch areas of HVAC and other building service systems. I suppose that we're already doing this frequently. Next is to check air handling systems, if they are providing adequate airflow and if sensors are calibrated. This is one thing that we actually have to check, right? So the usual preventive maintenance is at least per 6 months. So that is twice a year. Now, if we could go to having them quarterly, then that would be great. Most air handling systems have, especially for the centralized ones, they have their ducts all split up, and some have damages, and some are being sorry for losing the word, naipit, right? So they're being squished between 2 other ducts or whatnot. And it's best if we check those things, and if we're going to have the technical team, the engineering team, check those. Next is the exhaust fans. If they are functional and they are venting to the outdoors, right? So exhaust fans are very important in ventilation systems. It allows for pressure imbalance, right? So that we can have a regular airflow rate within the building. So checking exhaust fans if they are still functional and if of where they are exhausting, right? Which is linked to bullet number 4. Check the outside air intake regularly for potential risks such as exhausts nearby and provide proper clearance if accessible by pedestrians and other pollution generating sources. So there is a minimum intake distance, which is about 3 meters, but Verde, which is the green building system for the Philippines, is actually recommending 10 meters, right? So 10 meters from the outside air intake to any exhaust. So again, this is linked to the bullet number 3 because some buildings have their exhaust right beside the fresh air intake, right? So it's bad, right? So because whatever you're exhausting may be also taken in by the fresh air fans. Next is ventilation. Uh, the first bullet is to increase outdoor air ventilation per person by fully opening the door, outdoor air dampers, or reducing the number of people. So this is it's not ventilation per se, but ventilation per person, right? So if, for example, you have just an adequate ventilation for 100 people, then if you cut that in half, then you're having more ventilation for 50 people, right? So it means that we could dilute the air the air pollution well. Disable demand controlled ventilation. So some buildings have this. They installed this to reduce actually the energy consumption of buildings. This controls basically the fresh air intake of the building depending on the CO2 levels within the space. So if you have this, and it's better to disable them and just allow for full outdoor air. Implement a flushing system before and after occupancy. So this is operating the ventilation system 2 hours before and after occupancy. So if your office opens at around 8 a.m., then you should open your ventilation system, just the ventilation system, not the air conditioning. Okay, so just the ventilation system by 6 a.m. and 2 hours after. If you don't have, if you are, of course, in homes, right? So we don't usually have ventilation system there, just air conditioning. Then just open the windows 2 hours, 2 hours after occupancy, and then just leave it open so that when you come back, the air would be fresh. Next is operate at minimum outside air when not occupied. You can talk with your building engineers, your property managers, especially for the offices that are renting, right? So if they can just open their ventilation system overnight so that you would have total air exchange when you get back to the office the next day. The last slide is for filtration, right? So update or replace existing HVAC air filtration to a minimum of MERV 13 or MERV 14 if preferred, or the highest compatible with the filter rack, and seal edges of the filter to limit bypass. HVAC, if we could have MERV 13 for recirculated air as well as for fresh air, then that would be the best. A little better if we'd have HEPA filters, right? So HEPA filters is around MERV 16 to 17, which is very much, it filters out 99% of the virus. MERV 13 only can filter out around 95% of the virus. But the problem with HEPA filters is that it would require another blower to push the air through the filter. So the higher the MERV rating goes, the more dense the filter. The last slide is consider using local air cleaners or filters when the main HVAC filtration is insufficient. So this is part of the operations and maintenance, right? So we should check our air handlers, what filters there are, and what filters we can upgrade to, and explore other emerging and tested solutions. So one of the most preferred solutions is UVC, right? So installing ultraviolet lamps in the ducting and in the air handling units of the HVAC system. But exposure to this, right, in maintenance, and if your ducts have leaks, could deal with could produce skin damage, and of course eye strain and eye damage. Okay, other emerging solutions are for the filters. We have electrostatic precipitators, which could replace MERV 13 and MERV 14 filters. They work by charging the particles and allowing the particles to stick to electronic plates so that you can just brush them off later. Another one would be bipolar ionization, which is done through a device that generates positive and negative ions, right? And the ions stick to the virus, which they activate them. This is more preferred because it has a very low parasitic load, and then it also has very low impact on the power consumption of the air handling units. Okay, so I'll end with a statement again from ASHRAE. Key elements of strategy to limit the spread of the COVID-19 virus is to perform needed HVAC system maintenance and including filter changes, and to run HVAC equipment prior to reoccupancy. That's it for my presentation. If you have any questions, you can ask them, please.
Great. Thank you so much, Joel Jude, for giving us a great overview over the technical aspects here with ASHRAE input and some of your own observations. You know, it's like a science in itself, I think. And a lot of people that are in charge of offices, restaurants, we don't really understand all of the details that the HVAC guys and the maintenance people are working on, but this gives us a very, very good overview already here. And you are right, you know, if your air intake is next to a contaminated source or next to a car park, then you've got a problem. But one question I just wanted to ask you, you mentioned for homes, and all of us live in homes and we're trying to avoid the risk at home as well. You were talking about flushing before and after occupancy. Now, I think everybody has 24-hour occupancy in the home. Our electricity bill has gone up a lot. What is your recommendation for air circulation and air flushing in the home?
Just to maximize basically the ventilation, right? So study first where your ventilation comes from. I see from the question and answer here, which is more prone to coronavirus, an open air room or a closed ventilated environment. Yeah, it all links up to where your ventilation comes from, right? So if your ventilation comes from the street where a lot of people are passing by, then it's not so good, right? If your ventilation comes, if you are in a condo unit like 23 stories up, 23 stories up, then the ventilation there is quite good. So it depends on where your ventilation comes from. Just open the windows if you after using the bathroom, so that the humidity wouldn't go down, wouldn't go up rather. You just leave open the exhaust fan, right? So to exhaust the humidity, as you saw from Dustin's presentation, a humidity of 80% would be bad also. So yeah, those are the things. Just maximize the ventilation.
Great. As we are just here, you know, in the chat comments, there was a question. The question time is kind of later on, but as it's relevant to your presentation, we'll just take that now. Aside from air filtration, can we use liquid sanitizer after cleaning the cooling coils for the air handling units? Liquid sanitizer, will that do the job?
Liquid sanitizer, depending on what liquid sanitizers, right? So the most common that's being used for cleaning the coils is UVC, right? So UV lights. For the liquid, I'm sorry, liquid. I'm looking for liquid sanitizers.
Yeah.
As long as it's approved by your engineering office, right? So yeah, you could use those.
But I think liquid sanitizer would then only eliminate on the surface of the cooling coils, but it would not affect the air going through. It will not actually eliminate the droplets in the air, I think at least. But let's park this discussion for later on. And we have as well from Freddie a question, with regards to, is there an option that doesn't affect the performance of the AC system? I think that might be partially answered by the next presentation, Freddie, and you can come back to that question later on. I would like to introduce Tim now. Tim is in charge of Asia Pacific for the bipolar ionization product that he's briefly going to share with us. And Tim, I really enjoyed your presentation last time. That's why we invited you back again. So over to you, and please share with us what bipolar ionization can do, which I think is an amazing technology. I'm using it myself here at home with the family, both in the living room and in the bedroom. So maybe you can share your observations on how we can tackle COVID.
Thank you, Matthias, and good afternoon to everybody. I hope you can see my screen now.
Yeah, can you do share like the start the presentation? We can see it, but it's still in slide mode. Yeah, perfect. Tim from
Has it come
Plasma
through
Air.
now? Okay.
Excellent. Yes.
There's always a great delay between myself, the screen, and the internet, so you'll have to excuse that. I'm talking to you from the UK, which has some interesting aspects and takes on obviously COVID-19. I know the earlier, just to give you an idea, in Europe at the moment, there's a lot of outbreaks in food processing plants. And food processing plants run at temperatures of about 4 degrees C. So the scientists have actually discovered that COVID-19 absolutely loves that temperature level. Now, luckily in Asia, you don't have too many places with temperatures like that. But we do have other issues that we have to consider. You're in a much warmer climate, and air conditioning is very necessary to make life livable. Now, the WHO have finally, I think, woken up and said, oh yeah, COVID-19 can be transmitted by aerosols. These aerosols can remain suspended in the air for hours, in fact, in some cases, days. And air conditioning systems could assist with the spread of COVID-19. So my presentation really focuses on how we can remove viruses from the airstream. These are really proven ways, and we'll look at each one of these in detail, but we can use very fine filtration, i.e. HEPA filtration, and we can increase the air change rate into a building. We can use ultraviolet light, because ultraviolet light has been proven to kill the virus. Or we could use bipolar ionization. Now, each one of these solutions has an impact on the building. So let's just consider what those impacts are. And the first one, when we look at filtration in detail, most HVAC filtration systems are not designed for very fine particle arrestment. HEPA filters, which are designed for high efficiency particle arrestment, they have very high pressure drops. And the existing systems, in many cases, in fact, I would say in most cases, are not designed for these very high pressure drops. So we have to be very careful when we look at putting filtration in as to how the system will perform when we retrofit with the filtration systems that we need to look at now. The most important factor is that most HEPA filter systems, and we can see down here very clearly on this slide, the actual size of the virus, and I think Dustin has already confirmed this, you know, a HEPA filter is designed to capture about 0.3 micron diameter particles, and COVID-19 particles are between 0.06 and 0.14 microns. So, you know, we have to question ourselves as, are HEPA filters really an answer in the first place? And of course, with the increased power input that we're going to have to put into the system, is it an economic and viable solution? Ultraviolet solutions are certainly very, very good. Ultraviolet light, in studies done in the 60s and 50s by ASHRAE, have proven the effectiveness of ultraviolet light to kill viruses. There are, unfortunately, certain things we have to consider with ultraviolet. Now, using ultraviolet in the space is potentially a very good idea. However, of course, light will travel in very straight lines. So any part of the space that's shaded from direct view of the light itself will not be cleaned. Secondly, commonly used materials that we have in the workplace or in our homes are not UV resistant. So items like plastics, so our computer screens, our computers, in fact, our clothing would soon be deteriorated by ultraviolet light. And probably the most important factor is that ultraviolet light is carcinogenic to humans. So effectively, if we're going to use ultraviolet light in a space, then we can only clean when there is no occupancy in that space. So whilst ultraviolet has some advantages, it also has many disadvantages. The third and probably final solution that we've got at the moment is bipolar ionization. Excuse me. What we're doing is replicating nature, and we create millions of positive and negative ions that flood into the space from the air conditioning system. Now, these ions are known as nature's cleaners, and they will neutralize VOCs, kill viruses, bacteria, mold. They also agglomerate particles and they neutralize odors. They're very, very effective because they are nature's cleaning kit. It's not an artificial filtration or trap system that we're trying to use. In terms of the negligible, about 10 milliamp 2000 CA. And effectiveness, you can see my bit unable there. Hopefully you're back with us now. In terms of effectiveness, a lot of work has been done in independent testing to discover the efficiency of bipolar ionization. And we'll just get into that in a moment. A lot of people ask me, and I thought I'd put this slide in because it gives you a better understanding about how bipolar ions do actually work with viruses. There's a lot of misconceptions about how the virus is actually killed, but effectively the positive and negative ions surround the actual surface protein on the virus itself. And with the introduction of humidity, we actually cause some changes to the virus itself, and that's the carrying protein surface of the virus. We actually destroy the protein cover on the virus with the ionization. So that gives you a little bit more of an idea of how a virus is killed. Probably the most important thing is to look at, well, what testing have we or has the world done on ionization to actually prove it as a viable alternative. We did some testing with the Spanish government, the Spanish Military of Defense, ourselves and our distributor in Spain. The Spanish government were very keen to look at ionization, but in a very scientific way, and determine how effective it could be. We've got a full report here, and that report we can issue to everybody. It's both in Spanish and it's been translated into English. It is actually authored by the Spanish Military Defense. So we actually have very, very interesting third-party testimony. And the summary of that testimony is quite simple, that after 10-minute reduction, we got a 99%, after a 10-minute exposure, we have a 99% reduction in the air of the bacteriophage that was used to simulate COVID-19. Interestingly as well, we had almost an 80% reduction on surfaces. So ionization has an exceptionally interesting role to play in this in this current pandemic, and I think we're now seeing trends globally where people are actively looking at putting ionization from the word go into their buildings. We are certainly very busy everywhere with retrofits, but I think it's fair to say ionization is becoming almost mainstream, not as the answer. It's not the total answer, but it is a good solution, which is very cost effective, which is very environmentally friendly to getting the world going again. And I think that's what we need to do right now.
All right.
So, thank you very much.
Great. Thank you so much, Tim, for an excellent overview. And I think we could, sum it up as an effective solution that doesn't have any negative impact on power consumption in any major way or on human health. Actually, my own experience is it has improved our problem of some of the PM 2.5 and bad smell that we get from open fires in the neighborhood. And what took me by surprise after installing bipolar ionization into our aircon here at home, it felt that the aircon was running cooler with the same temperature setting. I don't know whether you've experienced that, Tim, but that was our perception here. So we actually pushed the temperature up rather than down, and I think that is saving us some electricity. So I would like to open up the floor for questions now. We've got about 15 minutes, but I'm okay with stretching a little bit over time in case we've got nearly maximum capacity. We've got currently 98 people online. It's only 100 people that can join on my webinar subscription. So we have managed it perfectly. I think we start with the question that Freddie asked. He was basically asking, is there any other effective filtration system that we can install that doesn't need to modify or boost the fan capacity? Correct me if I'm wrong, Tim, there is no negative impact on the fan capacity here. In this case, if it's not a classical filter, it's basically a device that creates the positive and negative ions, and that way cleans it up in the duct, but as well in the room, because those ions travel into the room. Is that correct?
Indeed, Matthias. In fact, the way to look at it is that filtration technology is trap and kill, whereas ionization technology is to kill in the space where human activity is. So it's far more efficient in terms of its killing rate for this virus.
All right, great. So let's go through the questions, and feel free to add additional questions, preferably in the question and answer session rather than in the chat box. We have one question that came up, and that was as well covered in the chat area, whether we are happy to share the presentations. I assume that is the case. We will as well provide some links. I know Dustin, uHoo has done a detailed study with scientific references on the underpinning rationale of the virus index and what are the recommended indoor air quality parameters. So that is something that we can make available. We will make it all available to Luz from OCAI, and those of you that are not directly linked to the Ortega Center Association, you can contact me via the email that was in the Zoom registration to ask for those documents, and then I will furnish them to you. So the question, which is more prone to coronavirus, an open air room or a closed ventilated environment, I think that was already partially answered by Jude. But generally, restaurants in Europe, the recommendation is eat open air as much as possible, because then you have the continuous removal of air through the air circulation that we have by nature, by nature's power. That is the best. So open air is the optimum scenario that we are talking about. But in an enclosed environment, we have the problem here. Our building designs and our air, the temperature and the humidity makes us feel uncomfortable. So yeah, there is a question here from Crispin. Do we need EPA registered for the disinfectants to be used as cleaning agents? I guess you're talking about US EPA. I think the US EPA has a list of disinfectants that they recommend. I don't know whether we have that in the Philippines as well. I personally believe that the passive solutions like bipolar ionization or titanium dioxide nanocoating for the surfaces is preferable over continuous disinfection, because continuous disinfection, if you use, for example, alcohol to disinfect your hands, 5 minutes later, if you touch a contaminated area, your hand is not disinfected anymore. So the liquid disinfectants have a short lifespan, whereas these passive ones, and I think it could help us to reduce a lot of chemicals and a lot of single-use protective equipment, gloves, and everything else, because when you use a disinfectant, you have to throw everything away afterwards. So my recommendation is look as well at the continuous solutions that can passively disinfect on an ongoing way. But yes, if you can find those registered and government recommended disinfectants, that should be preferable. So somebody wants a comment on the effects of upgrading of filters and HEPA filters for an existing centralized AC. Jude, can you take that question, please?
Sure, no worries. First, we, as Tim mentioned, right? So we have to check first if the air handling units can in fact accommodate such filters, right? So worst case, if it does not, okay. So usually, the design is to allow for just a MERV 6, right? So by installing HEPA filters, you're going 10 levels higher than what it is designed for. This is typical for most air handling units in the Philippines, right? So if you're going to install HEPA filters in there, you have to take down, basically, you have to add in another filter box. Then you have to add in booster fans just to push the air through the filter. So yeah, those are the effects with regards to the equipment, and with regards to the operating energy. Yeah, so that would go higher as well.
I think we'll continue the next question, maybe both you and Jude, and then we have another question on the chat box for Dustin after this. the ratio of putting air cleaning and disinfection devices for air conditioning systems like UV and plasma air ionization is 1:1, which appears expensive as we add up now to the installed system. Any suggestions how we can handle this? The first question would be, do we understand this question?
Yeah. Actually, I was reading it again.
Yeah, I think we might need clarification. Tess, maybe you can elaborate a little bit more on this one, but I'll take the next one for Tim, and then I'll go to the uHoo question for Dustin. Is there a need to put an additional rack to accompany the bipolar system in an air handling unit? Yeah.
No, there isn't. We can offer two solutions. One is a what we call the plasma bar, which fits before the air handling unit coil, which actually cleans the biofilm off the coil and ionizes the air for the space. Or alternatively, we can offer a duct-mounted system that we can fit into the supply air ducts. So there's a variety of options, and we would pick, or we can offer the best one to suit the budget, the site installation and the equipment. Thank you.
All right, good. I'll hand over to Dustin for the question here from William. How can we make a model to apply the uHoo virus index safety threshold in our own systems, just to have a safety check on how we are performing in terms of adjustment made from the HVAC? A question from William for Dustin. Dustin, can you answer this one, please?
Yep. Yeah, William, you can make your own adjustments. So we provide a dashboard where you can see all the data. And we also provide you tips on what you can do to what kinds of adjustments you need to do, because we will specify exactly what the issues are, whether it be temperature, humidity, CO2, PM2.5, or NO2, and we will provide you with some suggestions on what you can do. And if you don't want to do manual intervention, our whole system can be integrated with your building management system, and it can easily automate your air conditioning, your ventilation. So once a threshold is reached, it will automatically switch on or switch off whatever systems that it's integrated with.
Okay, great. Michael Padilla asked about the supplier. I can forward that to you, Michael. It's actually AOM Indoor Care. They are our co-sponsor for this event. I'll put you in touch with them. And Jude will answer the question on the UV and plasma air one-on-one. And Jude, you can maybe as well answer the additional question, how long to upgrade an HVAC system using HEPA and how much would that cost?
Okay, thank you. Oh, so for the first question, 1:1, right? The way I understand this question is that we discussed two solutions, right? UV and plasma air. And the way I understand the question is that you are you choosing in between the two? So if that's the question, then my suggestion would be to stick with just plasma air, right? Because it provides basically an active. So how does UV work, right? The UV works by treating the air that passes through it. So you have to get the air to pass through the UV before it gets treated, and then you get, basically what you're doing is you are gathering the virus into one place, and then you're going to release the air, right? By putting in plasma air ionization or bipolar ionization, you are making the air itself would be an antivirus, right? So you no need to pass the air through anything else as long as you have the plasma air ionization, except of course on the plasma air. So it releases ions within the air so that the air would be treated in the space. And I think that's also the answer for Michael's question. So plasma air will clean the air of viruses in the office when we are present. Yes, that's what it does. Okay, going to the next question, how long to upgrade HVAC system to HEPA and how much So now the rise of HEPA filters, right? The demand for HEPA filters is putting a strain on the supply chain. So how much is the one HEPA filter? It's around the numbers of 150 to 200,000 per HEPA filter. That is if they have supply. So it would ultimately depend on how long, or the lead time, right? How long they can provide the equipment for you to upgrade your HVAC system. This can be from around 6 months to 1 year.
Okay, we have the next question. How about for transportation like buses and trains? Does Plasma Air have a device for this? Tim, you have a device for buses and trains?
Yes, we do. Interesting, actually, in India, we've just finished testing of a plasma air system in the or for the Indian Railways for their carriages, and that's going live. That's a combination, actually, of a couple of ionizers in the air conditioning system, together with nano coatings on the actual carriages itself. We also have a car system. So yes, the answer is we've got a full range of systems for transportation.
Yeah, there is a follow-on kind of question here that's linked to that, and then we have another question for Dustin after that. I have already checked UV for aircon, and supplier said we need to put 1 unit UV per unit of aircon, which is expensive. I assume it's the same like plasma air. This will really require more funding to be able to make use of those solutions. That's basically a financial question, but maybe I can take that. Actually, the local suppliers of plasma air, they offer a pay-as-you-go system where you pay a monthly fee depending on your square meters. That is something that we can send to you. It's actually not that expensive. So you don't have to pay the money all up front. And that's made it attractive as well. When I talked with my dentist a month ago here in San Pablo City, he was complaining that he needs to do so much stuff, and some of these things, there's no supply. I told him, have you heard of bipolar ionization? He said, no. I told him about it. So a couple of dentists, nearly 10 of them now in San Pablo City, have bipolar ionization and nano coating now, and they're only paying a small monthly fee with the indoor care package that is very financially actually affordable. So that information can be supplied. Now over to Dustin. Dustin, can this, Nelson is asking, Dustin, can this system be applied to building using individual inverter aircon units, since we have replaced our existing old central aircon with individual type aircons? So can you help control them as well?
Yeah, the control for inverter types of aircons would have to be manual because it's not a direct integration, but there would be other devices in the market that we can control, and that device can control the inverter aircon. So we can go into more detail with that in a separate conversation. So we can still do some form of integration, but it involves a third-party product.
Yeah. Then we have Aldrin here. What is your take on photocatalytic oxidation as opposed to bipolar ionization? Have a supplier offering PCO technology, as it can be easily integrated to the HVAC system, especially for old buildings, which is limited or no provision for fresh air fan. So I think, Tim, that's a question for you. Bipolar ionization in comparison to photocatalytic oxidation.
Sure. The jury is really out on photocatalytic oxidization. The EPA have done some studies on it. It has some. They have some concerns with the carcinogenic properties that they've noticed. The great disadvantage with photocatalytic oxidization is it's really UV based. So it's more of a trap and kill technology. It doesn't actually work particularly well in a room, in a space. Effectively, it's a UV light with a Ti titanium dioxide shell covering on it. The theory being that it releases hydroxyl radicals into the space. Unfortunately, you can't measure hydroxyl radicals. And as I say, there is some concern of hydroxyl radicals and their potential health effects. So it's, it's a solution that's there. But if you look at the latest products coming out of the US, they're actually combining photocatalytic oxidization and ionization technology. So from our take, it's not really the best proven solution. I don't believe that any work has been done by the manufacturers of photocatalytic equipment in terms of their effectiveness on COVID-19, or indeed their effectiveness on particulate matter. So the jury's very much out on that one.
All right, thanks, Tim, for those comments. Dustin has to leave us for another webinar. We still have over 90 people on the call, so I suggest we keep it going for another couple of minutes because we still have questions coming in. Any last question for Dustin? Please ask it now in the chat or in the Q&A box, but I can put you in touch with him as well if you want to ask him a question privately or subsequently follow up with him. And we will make the uHoo Virus Index scientific document available. Luz says a thank you to Dustin as well. Yeah, great presentation. Thanks, Dustin. Enjoy your next webinar. And we have 2 or 3 more questions here that we will attend to. Is
right,
UV
thanks,
certified?
Luz. Thanks, Matthias.
Okay.
I'm off now. All right,
All
take
right,
care,
great.
guys.
Thank you so much, Dustin.
All right, bye.
By the way, Dustin is a Filipino as well, even though uHoo sits in Singapore, and he is the co-founder of the company. So it's actually something that the Philippines can be proud of, that one of its countrymen came up with such an amazing device and such an excellent virus index as well. Tim, I hope your cough is not containing any COVID droplets, but I assume you have bipolar ionization at home, so they will be dealt with. The next question is UV certified by WHO as a disinfectant treatment for viruses? Tim or Jude, do you know about this? I mean, I would say it's commonly known, as Tim said, and as Jude said, it's very effective, and people will certify it, but don't put it next to humans when humans are in the room. That's basically the bottom line. You have to hide the UV somewhere in your system, or you have to use it in the evening after everybody has left the office. You switch it on there. You definitely will kill all the viruses that are in the air. That's confirmed by various studies, but you can't use it with humans present because of the carcinogenic impact. That's how I would sum it up. Yeah.
Yeah, Matthias, if I can add, please. So, yeah, UV is accredited, right? It's accepted. It's widely accepted for systems that can accommodate the UV lights, right? So this is primarily for air handling units that have a separate room where they put the UV lamps on the coils themselves or in the return. So it's a separate room, right? So for if your air conditioning system has cassette type VRF system, right? No air handling units, just the FCU system that when you look up, there's a square thing over there that blows cold air, then definitely it's not applicable, right? So it's applicable for systems that can accommodate that kind of design.
Great. And then we can finish here off with the last 3 remaining questions, which I think are all addressed to Tim. So Tim, hopefully you can keep it short and sharp, and then we can finish by 3:10 latest. I appreciate we are overstretching the time already, but we still got 90 people on the call. That means you guys are still interested, so I keep going. How does bipolar ionization destroy the COVID-19? Maybe you can send Noel as well some of the scientific studies that go into more detail. And what is the difference between ionization and ozonization? which one is more effective, and maintenance. What about maintenance and operating hours, and before replacing it, how long can you run it? So Tim, this is all for you.
Okay, very quickly. Let's start off with ozonization. Lovely term. Unfortunately, ozone's a bit like UV. It's not very good for humans. Now, ozone will clean anything, but it'll also clean lung tissue of living organisms. So I don't recommend ozonization for cleaning of buildings, not anyway, buildings that are occupied. Maintenance requirements for bipolar depends very much on the system that you have, but the modern needle points, the brush styles have almost zero maintenance. And I think, as Matthias has said, if you go for the air care package from the company there, ANO in the Philippines, then that's all taken care of. So that's that question. Remind me, what was the last one? There were 3 points there.
Yeah, I think the main operating hours of the system before it needs to be replaced.
Yeah. The operating hours, you can operate that that system 24 hours a day, 7 days a week.
That's what I do. I have it on all the time when our aircon is on. Actually, it runs as well without the aircon, but there's a separate switch that I have to switch it on or off. And I have actually detected with my uHoo here at home that we have less PM 2.5 in the air now since we have installed it. So it has definitely had multiple benefits. I personally can highly recommend it. And thank you so much, Tim, for coming, if we can say so, all the way from the UK virtually to us for the presentation. Thank you, Jude, for an excellent technical and HVAC guy presentation. Dustin, he left us already. Luz and Okai for co-supporting this. AOM Indoor Care, Jeroen and Walter as well. We will give you their contact details if you need to get in touch with them. Contact Luz. Actually, I think after the last webinar, correct me if I'm wrong, Luz, they installed the indoor care unit as well, the indoor care system in the Okai office. So if anybody wants to see how it looks like with some, in a small space with split aircon units, you can visit the Okai office and see it there firsthand. The only thing you see is a small light in the air, but my wife as well said, well, it's so much fresher and so much colder now since we've installed it. Thank you so much, Tess, as well, and others for commenting that they found this very informative. That was the idea. We do a technical discussion. We talk about the latest trends. Remember what I said at the beginning. We want to inform ourselves as much as possible. What are the solutions out there that are cost effective, that can do the job, because we have a big challenge to get our economy opened up again, your buildings opened up again with confidence of customers to come back. We have 88 people still on the call. That gives me a very good feeling. You enjoyed it, you learned something. Thank you very much. Please give a virtual clap for all the presenters, for Okai and Salamat
And for
po.
you too.
Thank
for you too,
Luz.
Matthias. Thank you for always hosting webinars for us.
Walang problema. It's my pleasure.
And
I love doing
also,
this.
we're welcoming everyone or anyone who's interested to check out the system, the nano system that is now installed in Okai. They can come and see how effective it is.
The nano coating and the bipolar ionization.
And the bipolar, yes.
Yeah, great, excellent.
Thank you.
Thank you so much, everybody. And please contact either Luz or myself for the presentation slides or the scientific papers that we will make available as well. And have a wonderful day, and see you again, hopefully sometime soon. And actually, I forgot, I have another poll. Let me pull that up. For those people that are still here, I made a second poll question. Oh. Here it is, the second poll. I'm not sure whether you're still there. I think I just got kicked out for a short while. Something is wrong here. Are you still there? Can you still hear me?
Yes.
Because
Yes,
I have,
we can still hear you.
the funny thing is I've been kicked out of the system. I don't have it in front of my screen, so no chance for me to launch the second poll, but you can still hear me. So thank you very much. Great, enjoyed it, loved it. Stay in touch. Hope to see you again soon in real life, or hear you, or have you participate in another webinar. Thank you.
Thank you.
Bye-bye.
Thank you, everyone. Bye-bye.
Thank you also.